Hello everyone, my name is Bhargav. Today I can explain about the Newton backward difference formula topic. So Newton backward difference formula apply when values of the x are equally spaced. That is the difference between any two successive x values are same. Any two success values, these two success values are same. So we apply the Newton backward difference formula. So the non-backward difference from find out the value at the utmost end of the table. So we can find out the any value in the end of the table using the help of the Newton backward difference formula. So to explain about this sum given x in years and y in population numbers. So find out the value at a 1925th year. What is the value? What is the population in the year? So we use the Newton backward difference formula. Find this value. So construct the forward difference table for data. First of all, construct the forward difference table. For the data x, y, 1891, 1901, 1911, 1921, 1931, 46, 66, 81, 93, 101. We have 5 arguments or 5 entries. So we obtain the 4 central differences. So that is the delta y, delta square y, delta q y, delta power 4y. This is y0, this is y1, y1 minus y0. This is y2, this is y1, y2 minus y1. This is y3, this is y2, y3 minus y2. This is y4, this is y3. So this minus this. So this number minus this number, this number minus 3 minus 2 minus 4 plus 3 minus 1 minus 1 minus 2 minus 3. So we know the formula for Newton backward difference formula. Newton backward difference formula. Yp equals to yn plus delta yn into p plus p into p plus 1 by delta square yn by 2 factorial plus p into p plus 1 into p plus 2 by 3 factorial into delta cube yn plus p into p plus 1 into p plus 2 into p plus 3 by 4 factorial into delta power 4 yn. So we find out the value of p. We know x equal to xn plus ph. X is the first, we find which value we find. Xn is the last value of the table and h is the difference of the two successive values of the x. X is 1925, xn is 1931 plus p. We find the p value and the h is 10. 1925 minus 1931 by 10. So p, the value of p equals to minus 0.6. So we substitute the values in the formula of Newton backward difference formula. So yp equals to yn. Yn means the value. yn yn is the value of the last. This is the x, xn. This is the yn. So yn equals to 101 plus p, or value the p is 0.6 into delta yn. Delta yn means 8 plus p minus 0.6 into minus 0.6 plus 1 0.4 into delta square yn is minus 4 by 2 factorial plus minus 0.6 p plus 1 0.4 p plus 2 1.4 and del minus 3 by 3 factorial plus minus 0.6 into 0.4 into 1.4 into 2.4 into minus 3 by 4 factorial, and solve each one. 101 0.6 into 8, this is the minus 4.8. So we fix the values. We fix the number format in the fix. We obtain the values up to after the digit up to 4 values. So we can fix the value in the fix 4. So after this value is the 2 factorial 200 to 0.2. So 0.6 into 0.2 into 4 plus 0.48 plus 6 0.1 0.1 into 0.4 into 1.4 0.0560 plus 4 1 4 0.1 0.6 into 0.4 into 1.4 into 0.1 into 3 0.1008. So, and finally all these values 101 minus 4.8 plus 0.48 plus 0.0560 plus 0.1008, and the final value is the 96.8368. So the population in the year 1925 is 96.8368. We want the value in these two intervals, so we apply the Norton backward difference interpolation formula, but or sometimes we want the value in the first two values, so obtain the Norton forward difference formula table. So that is our option and problem. So we know that the difference for Norton backward difference formula, and we simply substitute the value of p and del values in the table. This is the del yn, this is yn, this is del yn, this is del square yn, this is del cube yn, this is del power 4. The forward difference table and the backward difference table values are the same but the notation are the different, so we can anytime only the construct the forward difference table, notations are different. So thank you everyone.